Good evening, everybody. My name is Jonathan Fite, and I'll be discussing doing message queuing inside of SQL Server this evening. I have at the end of this, or attached to this slide deck, which I will share with Julie, is a fully functional demonstration of this project that I have. This is actually something that I have actually deployed into my own production environment, and is doing quite well there. So I'm happy to share with you my adventures in doing message queuing in SQL Server. Sorry. There we go. So just brief overview, what we're going to do tonight. We're going to talk about the rules for doing SQL message queuing. We're going to talk about the business problem I was trying to address, because that is very important to understand the context of why and how I developed the solution the way that I did. Message queues in general, a few different approaches, and then we're going to talk about Artemis, which is my latest design. And we're talking about measuring performance, and then if there's time, we're going to walk through some code for Artemis. All right, so first rule, don't do queues in SQL Server. It's a bad idea. Don't recommend. See rule 1, and well, we're here because we're all rule breakers. So the real rules in SQL Server for doing queues in SQL Server is that your on queue and your DQ should not interfere with each other. You want to separate their locking mechanisms so that when you're trying to write to it, your readers aren't trying to read from it. And that's usually because the pattern works as you're going to enqueue a message, and then you're going to read that message, and then you're going to attempt to delete that message. You have a very shallow queue, which a good queue should be very shallow, which means a handful of records easily fitting inside of a single page. You're going to get a lot of XLOC contention, especially if you're a busy queue, as is my system, which is roughly 5,000 messages per minute on average. I peak way higher than that. So other rules is don't look at the queue while it's moving. You're just interfering with the smooth operation of the queue if you examine it. If you absolutely need to get row counts on your queue, you should use sys.partitions. Your count will be inaccurate. That's okay. It's in motion. You're just looking for averages, trends. You need to consider how you're going to recover when it stops working, when the queue fills up, when just anything happens. If your queue or your DQ operation is multi-threaded, first in, first out can only ever be approximated. That's because you have, say, 12 DQers, and they're all picking up messages at different times, or trying to at the same time. It might take a little longer, it might take a little less time. So a message that arrives, 1 second before another might actually live in your queue a little bit longer. If the order of operations for your messages matter significantly, then they need to be encoded as a single message. Do this list of work instead of do this bit of work and then another message saying do this bit of work and then this bit of work. Last bits, this is something that the naive approach that I replaced this with did not do, which was any type of performance metrics. And I had no way of analyzing what messages were in the queue that may perhaps have caused it to back up. Something that choked the DQ threads, for example. I had no way of knowing that after the fact. And then finally, you need to consider the Thanksgiving holiday problem. And what this is of course, everybody's off work on Thanksgiving. It's a nice 4 or 5 day weekend for everybody. And that's when the queue goes down. And let's assume worst case, nobody knows about it until Monday. Can your queue handle accumulating that many messages before it fails? All right. I couldn't find a good place to put this. This is for your on queue side. How are you going to send messages into your queue system? I use triggers because my business problem was I had changes in the database that I needed to indicate to a downstream system that such a change had occurred. So I use database triggers for all of this. When you're inside of a trigger, of course, you have a trigger can be either after or instead of. If you're doing instead of, you need to make sure you actually write your desired data onto the table. If it's after, that's great. The table data is already written. You have access to inserted and deleted virtual tables. These are heaps. They are written to disk, or if they are large enough, they're written to disk, but they are heaps. They're unstructured data. So trying to do any type of join or complex interactions with them is going to be painful, especially for super large data sets, which is important because your trigger needs to be able to handle a set of data rather than just one row at a time. Also inside the trigger is you have the option of doing if update and then put a column name in there, and it'll return true or false depending on if the calling DML included that column or referenced it. This can be very valuable as long as you're not using anything like an entity framework or other ORM. Most of those tend to read and write the entire row of data, regardless of how much data has actually changed. And so as a result, the trigger will always think that every column of data has changed when in fact it has not. So I don't use that very much. Some advanced topics that you can use is I use context info to dynamically sort of enable or disable the logic inside of the trigger. As with most environments, you're going to have some ETL processes that modify thousands or tens of thousands of records at a shot. And you don't necessarily want the trigger inside of it firing at that time. And so what I'll do is I'll have a check for some context info, which is data encoded in your session. And if the value it's looking for is there, the trigger doesn't execute inside of it. But it's still active, it's still enabled, so other transactions will send data through the trigger process. And then after that, your ETL process can send data to the queue system on its own. I use except to detect changes between the inserted and deleted. And then finally, a trigger order, which is you can actually specify trigger order. You can choose bookends, basically. You can set a trigger to be either first and or another trigger to be last. But you can't control the order within that spectrum. So you can say this trigger is going to be first and this one's going to be last. But if you have more than that, then you're going to have them in basically out in any potential sequence. Let's show some code. So in addition to that, I usually also have a table in my ERP system that's called basically queue enabled. Is the queue enabled? And I can flag it on or off. Let's say that the queue system goes down for whatever reason. I don't want my ERP system to stop working for any reason. And if you didn't know this, inside of a trigger, there is no way to catch an exception such that the outer caller will continue to work. So I can't say, try and throw a message into Artemis. And if you fail, then we're going to catch it. We're just going to silently ignore it. We're going to pretend it never happened. If an exception is encountered, no matter how many try-catch blotches you try and use, execute SQL statements, the transaction is doomed. It will roll out to the top and the transaction will die. So you need a way of turning off the trigger dynamically for everyone, which I do in this table here where I'm looking into is the queue send status. Is it enabled? Great. I also use session context, like I said before, as sort of a dynamic enablement or disablement of the trigger. So if I've said the special phrase, then the trigger will not execute. If you haven't, then the trigger will do its job. Here I am detecting the difference between the inserted and the deleted. Now this will only catch your inserted, your new or changed records. If somebody is deleting records and you need a message based on that, you have to do another lookup. You can probably reverse this and say deleted except inserted. In my ERP system, we don't delete, we only soft delete records, so everything's an update. And then I throw the changed ID values into a JSON string, and then I pop it over into the queue using the insert records procedure here. I use JSON instead of XML because, one, it's easy to read, and SQL Server is about 10 times more efficient at constructing and deconstructing JSON as it is XML. It's not as efficient as storing it. There's a dedicated type for XML. It's more efficient. But if you want to parse it more efficiently, then you should use JSON.
Sorry, can you repeat that? So JSON is better than what?
It is more CPU efficient. If you're parsing or forming JSONs, you're going to form it or decompose it. You want to use JSON. It's about 10 times more CPU efficient to do the same operations. From a storage standpoint, it's not as good. XML is better from that perspective, but disk is usually cheap. Way more, CPU is very expensive for SQL Server. Okay, so here are some queue patterns. I have actually used all, or attempted to use all 4 of these methods. 2 of them are in my current production environment. The naive approach version is what I replaced with Artemis. So I have attempted this on Service Broker, and you may be tempted the first time you look at using message queuing or asynchronous processing to say, like, Service Broker, this is the thing that we should use in our environment because it's right there. It's baked into Microsoft SQL Server. You don't have to worry about it, except that it's really not. It's received absolutely no love since it was deployed. I can't remember the last time I got a major feature update. It's one of the things that contributed to MySpace dying. And it's really complicated to get set up and get working. And I even indirectly through Stack Exchange talked with Remus Rasanu, which is who I recommend if you want to know more about Service Broker. Go find Remus Rasanu. Look at his blog. Fantastic, very deep insight. But even in our testing, I could not get Service Broker to perform adequately for us. It just kept dying, clog its system, its guts would get clogged with old messages, and it wouldn't work. A naive approach is just a straight table. You have a table, you're going to write to it, and your DQ process is going to read to it and delete from it. LMAX/disruptor. I've used this one. It works great. It's got some shortcomings. We'll talk about it. And then we'll go into very much more detail about the last one, partitioned system. So, problem I'm trying to solve. I have a very active OLTP system, 6,000 transactions per second on this system. I have users, I have mobile devices, they're all talking to the system, they're all, and in my opinion, a very less optimized entity framework business application. So it's doing a lot more work than it needs to do. It's modifying tables kind of out of sequence. Anyways, it's a mess. Anyways, lots of writes. Of those 6,000 transactions a second, my system generates an average of 5,000 relevant changes to the system. This key on this table changed, and we care. Of those, 20 to 40% are duplicates, depending on how long the time frame you choose to analyze. So, like if you collect say half an hour of messages, my duplicate rate climbs to 60 to 80%. It's incredible. But even at a very fast, short rate of, say, 30 seconds worth of messages, my duplication rate hangs around 20 to 40%. That's a lot of time saving later in the process because each one of those changes causes another part of the system to ask the ERP system, hey, what changed? What does that big chunk of data look like now? And if it's doing it for the same message 4 or 5 times, that's extra load on my ERP system that we have to pay for. So these downstreams, unfortunately, very, very visible to externals. They will notice when the system stops updating to them. And if it falls behind or anything like that, it becomes very nerve-wracking. By the way, the industry sector I'm in is we are transportation. We transport students in cars, tens of thousands a day. So we have parents, we have school districts very concerned about why our system may not be updating them properly. So what I was looking at is I needed to reduce my duplicates. I needed to actually be able to measure my performance. I needed to be able to recover faster when we did have an issue, and I needed to minimize the impact of any potential downtime. There's a basic queue design. You're going to NQ and DQ. I've covered some of this already. The metrics that you want to measure is dwell time. It's how long did a message sit in your system between on queue and when the DQ thread first grabbed it. That's called dwell. How long did your message take to be processed? That's when the message was picked up and when the process thread finished it. So together, that is your message lifespan, right? So your on queue to DQ time is your total message lifespan. You can't control the process time. What you want to do, though, is make sure that the amount of work that each message takes is approximately the same. We would have, in the same queue, we would have some messages which took almost no time at all. And then we'll get a slew of messages that when they receive it, it invokes 40 messages to come back into the system later. So those were called just sort of exploded the system, right? So one message could potentially take 10 minutes to process in the same queue as a system that took, a message that took 30 seconds. And they didn't have the same priority. The very fast message was a GPS update. This vehicle moved. We need to display this downstream. But the longer message was, hey, go ahead and forecast trips for this passenger for the next week. That would take it forever. And they should not be in the same queue. They did not have the same importance, and they didn't have the same work type, so they couldn't scale properly. All right, we didn't really care how long it took to schedule trips for a week out, as long as it finished within the day. That was fine, but we desperately needed to get GPS breadcrumbs out. So you have to create multiple queues, which allows you to then allocate DQ threads appropriately. All right, another sequitur here. Some hints that were useful in working with queue systems. Normally, my approach to writing queries is that you should start with no hints, let the engine figure it out, and probably do a better job than you will initially. These systems are special. I desperately need them plans to not change. It's doing the same operation. I want it to always do one row at a time. And so you force a couple of options here. The first one here, called lock timeout, is very helpful. You can use it outside of queues as well. What it does is it says, issue your lock timeout, say 1,000, because it's the number of milliseconds that you're willing to wait for a lock to be acquired. Write your big blocky statement, and if your big blocky statement can't get its locks within the timeout period, it just gracefully exits, rather than waiting in the lock queue, blocking further downstream statements from completing. I do this a lot when I'm doing some maintenance jobs, and I want to make sure that they don't interfere with index maintenance. Like if for whatever reason it's firing off at the same time on the same table, it has a lock timeout of 1,000, I'm willing to let it back off. We'll just try it again later. Another hint that I use in queues especially is read past, which lets the DQ threads read past any rows that may be locked for whatever reason. It lets the DQers grab a row to work on, which is important. You don't want them sitting there trying to wait for a page to become unlocked and available to write to themselves. And then up delock and row lock, when you're modifying records on there, you have to specify the up delock if you want row lock to mean anything to the system. So they almost always go together. And I also abuse output from statements. Instead of touching a record twice, I will just update or delete the record and then catch the output of what I deleted at the same time. So my queuing system here locks, does a soft lock on the record itself. There's a column for is locked and a date time that it expires. I basically attempt to lock the first record it can find. Meaning I do an update statement and then I use output that, rather than the other approach of selecting the row that is available to me and then coming back with another statement to update it to set the lock values. You don't want any cross-threading there. So your basic thread, basic queue is what I replaced, what I had. You had a non-queue, single table, and the new DQ looked like this. Grab top one, lock the message, do the work, and then the log message was really not done, and then delete the message. Like I said, that delete message caused X-lock on a very shallow queue. That's a page, which means my on queue would jam into it. Also, my on queue was not necessarily the best. Some of that entity framework garbage would write a record. It would cause a message to be tossed in there part way, and then the locks would be held on the queue table until the transaction had finished. But the transaction is trying to grab 100 megs of data out of the system. Again, because the entity framework is terrible, or the way we did it was terrible. I have words with the developers occasionally about this. But so it would take time for that 100 megs to leave the ERP system. And during that transaction time, it's locking my entire queue table. Now my DQers are unable to do anything. They time out because they're an application code. And then they have to restart. So here are the problems with that approach, especially on a shallow queue. You're all operating within the same page. If it's a deep queue, you're operating your on queue and your DQ thread queries, if they're not written appropriately, can drift because suddenly a different plan makes more sense. So I had a lot of page latch and write log and contention and blocking, and no one could really explain it. We were recycling things. We were getting system downs every week. So the LMAX disruptor, this is the one that I read articles about this. I did not come up with the idea for doing this in the queue system. As far as I know, I may be the only person who's written a production version of this, and I'm actually doing production data inside of it. But LMAX disruptor, it's a very nice queue system. You pre-grow your queue. You arrange slots in your tables. Your table is enormous because again, you're handling the Thanksgiving Day problem. So you have 5 days worth of messages in my queue. So you pre-grow your table and you have slots. So each row is a slot, and you use a bit reversed index so that the next logical slot is not physically adjacent. So it's in a different page. Basically, you're smearing your data across there and you're writing to one page at a time. So you don't have page latch. You don't delete records. You clear your slots. You update the values back to null. So you don't need to take a hard X lock. You can take a slightly softer lock because you're just setting values to null. DQ. Anyways, it's not without its flaws. Its advantages were that compared to the naive approach, this one, once we got it in and we teased our way through the various bugs that we found, it worked. We haven't had a single system down on this guy in 3 years. So it's just functioning. And messages go in and they come back out, but it's not perfect. So this is how your queue is arranged, big loopy table. You have some things you have to watch out for, of course. Your in queue and your DQ threads, because the table is never empty. You can't let them pass each other. It is a hog as far as resource goes. It's a CPU hog because it's constantly trying to calculate a bit reversed on a big int. And it's also a disk space because you've pre-grown your tables enormously. And it's an IO hog, which means in Azure managed instances, I've had to grow the table even more in order to get it to perform adequately. And honestly, it is complicated. If you look at the code for it, you're going to spend a long time wrapping your head around it because it uses unnatural concepts to a SQL Server developer. Does work though. Does work. And when we had on-prem hardware, I would have said it was the greatest thing since sliced bread. But we don't, which led me to develop Artemis. What was what I call Artemis. So developing this, we needed to replace that naive approach, that single table. It was not working for us. Like I said, we were getting system downs every week, regularly. I had to avoid the high resource utilization that the LMAX disruptor approach took, because again, I'm in Azure, I can ascribe direct cost to CPU burn. I had to reduce downstream work by removing duplicates. We'd already noticed that duplicates were a problem because during the system downs, when the queue was at 150,000 messages deep, I could dedupe it down to 30, and then it would clear in a reasonable time frame. So we knew that was a major problem for us. We had to be able to recover faster. We had to be able to log the data and provide metrics. And of course, most importantly, I had to make a cool presentation. So Artemis's queue structure. It uses, the payload is a table name and a key value, basically a key type and a key ID. So that's what our ERP system calls out. It says this table, this ID, something changed here. The DQ thread needs to go and build up a new message using that information. We have lock control, which we use an is locked column, which is a bit, an expiration date and time, a process count, so we can see if a particular message perhaps is poison. If it has to be picked up more than once, that means obviously it's causing a defect, a bug somewhere. We have some metadata. Again, this is the metrics. Date the message is on queued, the date it was up for DQ, and the date it was DQ'd. And then the special sauce we use, there's a column called partition offset, which is a small int which indicates which partition that row belongs in. So, message sequence. It's a lot of moving parts, but it's easy to understand. It's doing a couple of simple operations every step of the way. Message arrives, it's a simple insert statement. The partition it chooses to select to insert into is between 0 to 59, depending on the second that from the timestamp that it's being inserted. So in 5 seconds, I can safely clear any message that's older or within the last 55 seconds. Ignore a 5-second window on either side of now to catch ones that are on queue in the next few seconds and the ones that have already or may still be writing, just to cover myself. I then have a sweep job. This is a SQL agent job. It does one job per queue. So these steps don't interfere with each other. The first thing it does is it moves anything from those on queue in the second partitions, which is 0 to 59. It moves those into the 98% partition. I then use a partition swap, low priority wait, from the on queue table to the dedupe table. I then move from the dedupe 98 partition to the dedupe 60 partition. I then do a second phase, which is where this is the part where I deduplicate the data. I deduplicate any data that's in partition 60 on the dedupe table. I move the duplicates to another partition 99. Any non-duplicates, I move to the DQ table, partition 60, because they stay in that partition because I have to manually update partition offset. I'm not letting it be a date or anything like that. And then I move them down to the DQ and then finally down to the DQ partition where the DQ threads can read the record. The message will then, the DQ thread will then lock, work, and then DQ the message. When it DQs the message, it moves it to DQ 99. I have another phase in the sweep job. The sweep job just keeps going down that tick pattern. It just does that in a loop. It sleeps periodically. It before moving to the DQ table, it looks to see if it's shallow enough. And that's so that it can wait longer to deduplicate messages, because the more messages it has, the more efficient it deduplicates them. And so the sweep phase that moves from the log moves from the dedupe 99 to the log 99 table and assigns the metric. So there's a log table where all the messages are kept for a period of time, mod 60. So 60 up to 60 days worth of actual messages are in the log table using the same 0 to 59. And then I perform metric analysis on just what's in the log table. I don't look at the DQ table directly. If I need a count of what's in these tables, there's a view I've created that uses sys.partitions to assemble this into basic numbers. It says on queue, DQ, dedupe. It gives me counts for all of those. So when I'm moving records around, I will just update the partition offset value. When the DQ system is done, instead of deleting the record, it just updates partition offset to 99, and then it's done with the record. I let the behind the scenes engine drop that row into that partition. When I'm moving from, whenever I can, I swap partitions with wait at low priority with a max duration of 1 minute and abort after wait self, basically. And what this allows me to do is to, again, low priority. So I have issued I want to swap this partition, anything, and it just waits for an idle second. That's all it needs, is an idle millisecond to grab that partition and shove it wherever I want it to go. At the end of that, it waits up to 1 minute. You can set it up higher than that, but I want 1 minute. And then I've told it that if you can't get that lock, that you should just abort, just die. We're gonna let the on queue and the DQ keep doing their job, because again, I don't want to interfere with them. And then I have sleep statements periodically. In my production environment, sorry, I got ahead of myself a little bit. Here we go. So after deployment, the first thing, no more system downs. It's, again, this system is running rock solid for the last 6 months. No problems. It recovers fast. We've had, during those teething issues I was talking about, we would have some times where an on-queue thread would just hold that on-queue table lock. And I could never, even with partition swap, get an idle second to shove that partition over. And so I did have messages accumulate up to 100,000. Again, 5,000 a minute, it goes fast. But once we got those messages over, it automatically deduplicated them, and it worked great. It did exactly what we wanted it to do. On-queue and DQ don't block each other. The developers couldn't tell me, but I suspect strongly that the DQ threads were being blocked repeatedly on the on-queue threads in the old pattern, given how fast it seems to be able to DQ things now. Again, they don't have any metrics, so I can't prove that. I didn't have any metrics on the old system, so I can't prove that either. We exposed some defects. Again, those long-running transactions on the on-queue side. It does rely on an agent job, but that's fairly reliable, and you have lots of processes in place for monitoring agent jobs, so you know if it stopped working or it had an error. Lots of pieces, but not truly complicated. If you looked at the code that it's doing, it's just doing update, swap partitions. That's the hardest, that's the most complex piece, is the partitioning. This is actually incorrect. I thought it was 75,000. I was looking at the wrong one. It was 75,000 in 1 hour, but of those, 35,000 were a duplicate. And my average DQ time is 40 seconds with a standard deviation of 0.77 seconds. So very metronome precision of moving data along. All right. So we're talking about measuring performance, because really this is, where this system really shines and where a lot of systems fall apart. If you used Service Bus or if you used RabbitMQ or any other off-the-shelf like true queuing system, you're going to get metrics that look a lot like what this does. You're going to need to retain your message history. You have to know what you attempted to send downstream so that you can check for poison messages, so you can check for patterns, and like this particular message type takes forever. Why? You need to be able to alert on this. Is the queue falling behind? If the queue depth is higher than X, you need to be able to know about it. But you also need that query to not block the rest of your system. So for analyzing such a busy queue system, again, 5,000 messages, 75,000 an hour, the way I analyze them is I break them up into, I use an 80-20 rule. I take the 80% of my fastest messages and I figure out what the max time was for those. So I know my 80% of my messages took 40 seconds. I then look at the 80 to 90% fastest messages and look at how fast did those go. And then I look at the last one to know how fast was the slowest component. Because you're going to have messages that take longer. You're going to have messages that go significantly faster. Your average may not be a good way of looking at this side. Are most of my messages within my SLA? We've had occasions where a message, for whatever reason, got lost, abandoned, forgotten about, and it may live for hours before being dequeued. That's going to throw your average off. But by and large, your 99.999% of your messages performed within your SLA. All right. Are there any questions before we get to looking at code?
So you could type your question in the chat if you're online.
I am. I'll look at the chat. I don't see any. All right. All right. So we're going to look at some code.
I remember you mentioned you had some kind of a cadence.
Sweet job.
Yes.
Okay. Yeah, we can certainly talk about that. Let me scroll down to it. I have in this solution, which again I will share with Julie. I have, here we go, some scripts, which is basically scripts. So here's a sweet job template. Sure does not seem like it wants to do that at all, does it? Oh, there it goes. Okay. Let's make some stuff room over here. Let's see, can I zoom? There we go. All right, so this is the sweep job that runs. You just need to create one of these for every queue that you have. Each queue has 4 tables I was telling you about, has an on queue, dedupe, DQ, and a log table. I have a stored procedure that will create those for you. You just tell it what you want to call the queue. But you need to create this sweep job here. And again, this template will work with any of them, and you can adjust some settings in here. So of course, you tell it what queue you're working for, what do you want it to work on. You tell it the max runtime in minutes. And I do this to conserve sysjob history in MSDB. I usually let the SQL agent job run for 60 minutes at a time, and then it will die, and it'll start up again the very next minute. It's set to start every minute with a max runtime of 60 minutes. That lets a good compromise between keeping sysjob history from basically losing any potential other history that you may have in there, but also avoid long-running job. If your tolerance for long-running job or SQL command is higher, you can crank that up to as high as you feel comfortable. Exit on error. If any of the child store procedures return an error or an exception, do you want the job to die? Up to you. Errors are, any exceptions that get thrown are also logged in an error table for later analysis. And the sweep job itself has its own logging table called sweep log, where it writes its step, what it's doing, how long it took it, and it just gets endless after that. And then we have some timing intervals. How long to wait to check for on queue? So do we want to wait basically the maximum time we want between checks of, is there anything to move from on queue to dedupe? Do you wish to deduplicate? You can basically enable or disable that. Row in target threshold is how many rows in the DQ table do you want to have in there before you move anything into it? Again, I had a very good reasons for if the DQ table is busy, I don't want to add anything to it because I can wait longer and deduplicate more messages. Because again, the longer I wait, the more I deduplicate, the less work the system has to do in the end. But you also have another variable there, forced to DQ in seconds, which is how many seconds do you want to wait at most before you just give up and you move more messages over to it anyways. Sort of a fallback if your row depth isn't cutting it for you. And then another check for DQ in seconds. How long before we should check again? So if it checks the row count and it's too high, how long do you want it to wait before checking again? Basically, I set to like 400. I can't remember all my settings actually, but they work for me. Another thing that you can do if you're having issues with this whole sweep process is you take this script and you paste it into an SMS window and you plug in a job debug to 1. And then the max loop time will be like 5 minutes and it will output a whole bunch of stuff to the screen for you. And we'll see that in a second because it is filled with debug statements. Here are my variables. 15 seconds to wait between checks for on queue. I have deduplication enabled, rows and target threshold. If there's 400 rows in the DQ, I can afford to wait up to 15 seconds before trying again. I want, after 5 minutes, I want everything to go into the DQ table regardless of any other condition. Sorry, I'm getting hard to control the scroll. I don't know how far I scrolled there, but some additional variables. Most of these are control or while it's processing. Do that. So a main loop, I'm waiting for the time to exit the main loop. That was, I put 60 minutes. So that time to exit the main loop was calculated and it's stored. We have here, we're starting. Setting some wait time. More wait times. And told you it was full of debug statements, right? I did mention that. There we go, some actual code. So this part checks, should we run the command that runs from dedupe to dequeue? The reason this runs backwards is because when you're doing partition swaps, your target must be empty. And so you'll see that a lot in the procedures that this runs when we get inside them, that it checks its landing zone first, and then it does the move. So it kind of a little bit backwards, but it doesn't matter if you go backwards or forwards because it does it in a loop. So it'll get there. It'll get there. So here we are. First thing we do is we check if we need to move anything from the deduplication table to the dequeue table. We check our statements here. And then it executes the store procedure USB sweep to dequeue, and then resets some variables to check again. The next thing we do is we move from the on queue to the deduplication table, running sweep to dedupe. And that's it. It's 5 times longer than it needs to be because of the debug statements. But we're going to go into these store procedures now. So we're going to sweep to dedupe.
So when you talk about duplicates in here, what kind of examples do you have for duplicate data?
So we have mobile devices that constantly send their GPS locations when they're talking to the system. They're not supposed to talk more than every 45 seconds, but they do. So breadcrumbs is one reason. Another reason is that, let's say, when they arrive at a particular stop, well, that may update arrival status for all of the passenger records for that stop. So that's one vehicle stop, and then 4 passengers get modified as well. And then their GPS location gets modified. So that's now 6 keys that could potentially all be tied to the same run, the same message.
So with your options there, if you have potential sources that can have duplicated what those ones you want to have messages that should always be logged in with that in a separate queue from the ones that potentially.
Yeah, as much as you can. Yeah. We've not done that. The way we broke it up is each queue is a downstream message type. By far, trip status is the one that gets vast majority of our workload, and that's where most of our duplicates happen. But we also have a passenger document with all the information about a passenger. So when some passenger data changes, that causes an update to that document. We'll have a service provider change or a driver change. When any of those pieces change, we may send an updated message for that. But by the vast majority is our trip status. And so yes, ideally it would be a single queue, but then you also want your queue system to not know much about what it's doing. You want it to be kind of stupid. You want it to, like, all I do is I accept keys, key value pairs, and I'm smart enough to know that this key value pair is the exact same as this one over here. So I'm going to deduplicate this. You don't want it to have to think too much. You want, if it picks up a message and it calls back to the ERP system, and the ERP system says, oh yeah, you actually need to do these 6 things instead, what that procedure should do in the ERP system is shove those messages back into the tail of the on queue side of the queue system and let the message fall off. But you don't want too many brains in your queue. It shouldn't have business logic. Sure. So the question online is, are these queues in SQL Server different than Service Broker or other message queue alternatives? Yes, they are. I talked briefly about attempting to use Service Broker to satisfy my business needs. It did not work well for me. Service Bus, which is an Azure Service Bus, is great. We use it internally as well. We also do RabbitMQ, or not, we don't use RabbitMQ, but it's another queuing alternative. And if your application supports doing something like that, like if we'd had a single point of entry between the application to the database, changing the application to write a message onto Azure Service Bus would have been far better for everyone concerned. Service Bus is way more scalable. We just throw money at it. It's way more performant. And additionally, I don't have to manage it, which is another thing. These queues are in SQL Server because our application, that's where it is. We have so many different ways data gets into our main ERP database that the only way for us to do this is to have basically a trigger sitting on that table, detect the change, fire a message off, and have another system work on it. Our internal discussions, we actually talked about going straight from this queue to Service Bus, but you can't, with managed instances, you can't write without using the CLR, which I don't know, maybe you can do that, write directly into Service Bus from inside SQL Server. There is a preview feature which will allow you to do that from Azure SQL database. You can write directly into a REST endpoint. It has to be an Azure REST endpoint, or use, I can't remember. There's a workaround. You can use externals as well. But managed instances, we're limited to what we can use. There we go. So this is the procedure that moves from the on queue to the dedupe table. We're going to go through here. This is where we're setting up some variables, parameters, etc. We do a lot of logging. Because this works dynamically, these procedures use, I'm sorry, am I over time? No, okay, apologize. I use dynamic SQL inside of the stored procedure to generate all of these commands, because the queue name can be whatever you want it to be. So the first thing we're doing here is we're checking our target in the dedupe, and we're making sure that it's clear. And we do that by updating the partition offset to 60 on the dedupe table where it's not already set to that. We do the same thing for partition 98. This is actually, confession time. I took this from our on-prem code and I removed all references to my internal systems. That was a legacy step. It's still in there. It doesn't hurt anything to have it there. Logs the exception if it cat one. Then we're going to move from on queue 0 to 59 to on queue 98. We do here, this is the read past hint. We do that specifically so that if an on queue thread is holding its lock for longer than it should, we can at least get something out of the system. It was more important for us to keep moving than to, rigidly ensure that we had first in, first out order. We were willing to abandon messages to be processed later if need be. And here is the first partition swap. I've my initial approach with this is I just had the raw alter table switch partition statements in there, but it takes a non-zero amount of time for that statement to work, and it doesn't check to make sure that there's work that needs to be done. So I found it was actually much faster for me to both check to make sure that the source had data in it and that the target was empty before attempting to issue the command. So I issue these only when absolutely necessary. The other thing I really love about the later versions of SQL is this partition function here, which basically is I'm using partition offset as discrete values. And again, I have swapped to something I didn't mean to. I apologize. Again, putting in discrete values, I can just say move the partition and call that partition function, and it returns the whatever partition that actually ended up being on, which I think was like 61 or something, maybe 62. That's discrete value. I think that came in not 2016, the one after that, 2017. I think that was 2017. Being on managed instances is great. I get to play with all the latest toys. That will hurt you if you're trying to use this project directly. There are some things in there like that function, and also I use generate series in the project as well, which is another 2022 only function. But you can use any table value that generates you a series as a workaround. I'll leave that to an exercise to the user. This is the backup method because those because these partition swap requires an exclusive schema lock on the table, not just the partition you're trying to move. So those long running on queue statements that would hold that lock open was preventing my partition swaps from actually doing anything. They were just kept dying and then nothing would happen. So I have a backup method here where it's trying to say like, okay, so did partition swap work in the last couple of times or not work? And if it encountered that, it logs that it did that, of course. And then it does this method where I abuse the output clause to delete from the source table and the same statement insert into my target table with the read pass temp. I stuck with the partition swap both because of the wait at low priority, but also it conserves I/O on the system. You're able to swap the partition without incurring the I/O cost of actually moving the records around. And I do enough of that with all my update statements that I'm throwing around all over the place.
So what are you doing partition swap? What is it accomplishing?
One, it lets me move at, like I said, the wait at low priority.
Yeah,
It,
but like, is it like moving the data somewhere for like archiving purposes, or what does it actually do with the data?
moves it from one table to another, or even within this, not within the same, but moving from one table to another. Maybe this might be a visual example of what a queue looks like. Sorry, queue, not that. So the queue here, we have a table here called on queue, and another one dedupe DQ. I'm using partition swap to move partitions from one table to another. That lets me do, like I said, the wait at low priority, which was important, but it also is a schema only operation. There's no data movement underneath the hood when you do that. Using partitions lets me also do something. There's a layer beyond row lock where it'll do a partition lock and then a table lock, which also helps prevent table lock, and I get better isolation between the partitions on the same table.
So when you put it in one table, you're doing partition swap, and it's just basically taking that data throwing a new schema on top of it, essentially assigning it to a table.
I look at it like a partition as a binder. And we're doing a partition swap, or a partition swap. I get to take all the pages out of that binder and throw it into another binder. Whereas traditional methods, you would have to actually pick up the page one at a time and move them. This delete and then output statement that I have here, it works and it's fairly fast, but in order to avoid lock, to do 5,000 at a time, because I don't know how many records are going to be in this table. It's 100,000 deep. I don't want to do a single operation for this. And it's physically incurring the IO cost of deleting it out of one table and popping it into another. So that's 16 kilobytes, page read, page write, page read, page write. Whereas a partition, just the whole thing moves. Then here we move from so we've landed in, oh, we're doing that again. So we're doing it again because we are paranoid about messages getting, if the sweep job stops for whatever reason out of order and messages are stuck in tables in the middle of a state, I have to make sure that they move. So that's why I do the same operation a couple of times. If it's empty, then no harm, no foul on it. Otherwise, it just keeps things moving. That's it for sweeping to dedupe. Sweep to DQ. Does much the same, except it has a step where it looks at the contents of the dedupe table and just basically uses a row number to compare and say, like, does this key value exist anywhere else in the set? If so, toss it out. It's a terrible operation. It's extremely expensive, especially on a super deep queue, but it is so worth it from a low perspective. The only way I'm able to get away with this is the fact that it's its own table. The on-queue threads can't see it, the DQ threads can't see it, so nobody else is touching that table except the sweep job, which is so important. And I don't know why my Visual Studio here is so funky. We're nearing up on time, 15 minutes, I believe, or 10 minutes now. Any questions about what we have so far? Do you want to see a particular part of the system more closely?
With the dedupe, you said you used what number for that?
I'll show you this.
Is that just basically you're doing a number on keys and then anything over one, you're just
Yeah.
rid of it, essentially?
Yeah, I move it to another partition in the dedupe table because I keep all of it. Nothing gets truly deleted. Landing zone is clear. Nope, I'm sorry, that's the wrong procedure. There we go. Yeah, substituting row number. Wherever it's more than one, I mark it that it was a duplicate by setting its process count to -1. That's just how I internally know that it was a duplicate. And then I will move it into partition 99, and a separate process comes along and grabs contents of partition 99 and moves them to the log table. Before I get too far off, the queue metrics that we have here, there's the queue depth, of course, which is just the table name and then how many rows are in each of these sort of categories here. So the on queue is 0 through 59, and then a couple of other things. I usually just alert off of if the total is higher than threshold. My metric columns, I have for that specific minute, or in the 15-minute roundup and roll up and the 60-minute roll up, and the other two tables are the same concept, right? In that roll up minute, how many were on queued? We have a concept of roly-poly. These are things that get rewritten back to the queue. It probably won't work in anybody else's environment. I didn't get a chance to rip it out. It won't mean anything. It'll just be 0. Duplicate count is how many duplicates were encountered in of the messages on queued. How many of those were eventually determined to be a duplicate before they got to the DQ table. Then the DQ count was how many in that minute, how many messages were DQ'd in that minute. So separate from the on queue. The rest of these are all stats about the messages that were on queued in that specific minute. Process count average and standard deviation. Duplicate dwell, how long did a message live in the system before it was marked as a duplicate? Work time, how long was the message worked between it was locked and when it was eventually DQ'd. That lets me know if the DQ threads are choking or if a specific message is larger than normal or takes longer than normal. And then I have DQ percentages all down. The rest of these are all about DQ. So from on queue to DQ, how long did that take? The average, the max, the standard deviation. The percentage of messages that were 0 to 15 seconds, 15 to 45, 45 to 90 or 90 plus seconds. And then the NT, which uses the intile window function to order the fastest 80% messages. How slow was the 80% of the fastest 80%, the next 90, and then the 100 max. And that's how I go back and observe performance, and I can log stuff. The other thing that might be interesting to look at is how do I keep these tables clean? The sweep log, the error log, the queue depth, they are actually partitioned. They're using a partition function that again, another one that I stole from Thomas Ketcher. But it uses a partition offset. Up to 500 days of data is in there. That is a computed column based on the days between when the record was added and the current day. No, between epoch and the date it was added, mod 500. So it fits into a partition between 0 and 500. It'll fit in one of those slots. All the same day's records are on that partition. I then have another procedure called log partition rotate here, which you feed it a table name, you tell it how many days worth of data you want to keep, and it will go through and look at that table, and any partition that is not within the last, say, 90 days, it'll just drop the partition instead of deleting that.
So I understand you're creating the concept of partitioning the column, setting it, and beyond that, how are you affecting SQL Server to actually do the logical, its internal partitioning and match that, or is that just?
That is, sorry.
I know that question needs to be dragged out and shot. You know what I mean?
I do. So here in the storage, I have defined a partition function for queue, which I swear if it would load, you would see. It's just a small int, and then I've defined partition values, 0 through 60, and then a couple in the 90s for me. And then I have a partition scheme that uses that queue, because you have to have a partition scheme based on the partition function. And then in the table, definition. Okay, I'm sorry. It is all in the code. If you look in the add queue stored procedure that's in there, it builds the queue table, and it basically says use the partition offset as the partition value for the key. All right.
So thank you for attending. This was recorded and it will be on our YouTube channel, and I'll put a posting out on our meetup when it's available. Thanks again.